So today I will discuss about climate risk assessment. And as you know, uh, the basic difference between weather and climate is weather is uh, the pattern of the climatic parameter for one single day. Pattern of climatic parameter for one single day. By climatic parameter, I mean rainfall or precipitation, because in foreign countries we must include the snowfall also. It is extremely important in case of foreign countries, not in India. So rainfall is one parameter. Second is temperature, both land and surface temperature. Third is humidity. Four is wind speed. And five is the duration and fetch of the wind. So by fetch we mean, what do we mean by fetch? Fetch means the distance that a wind can cover without being obstructed. So this is known as fetch, and duration means there is a wind speed. For how much duration that wind speed is maintained, this is wind speed or wind duration. Although these two parameters are considered as passive climatic parameters, however, these four parameters, precipitation, temperature, and humidity and wind speed, is included as climatic parameter. Now, pattern or behavior of this climatic parameter for one single day is known as weather, and the same weather pattern for 30 years is known as the climate of an area. The 30 years weather pattern of a location is known as climate. And now what is happening? Due to the increase of GHGs, this climatic pattern is being observed to be changed in various locations of the world. Due to the increase of GHG gases, global warming is taking place in most of the areas of the world, and in some area, global cooling is also taking place due to the increase in GHG gases. And this global warming and cooling is causing the climate pattern of location to change. And when this pattern of climate is changing, different type of hazards, which is also known as climatic hazard, is being created, like the both intensity and frequency of extreme events, rare events, has increased compared to the last decade. Now, by this extreme event, I mean high intensity rainfall, storm, that means cyclonic storm or hurricanes, their intensity and frequency has changed. And also the onset of monsoon in different places of the world is accelerated. That means if in some place the onset of monsoon is, suppose in case of, in onset of monsoon is from June, it is observed in the recent decades. The same onset of monsoon is observed during the May month. Now, these are the change in climatic pattern that is being observed in various places of the world. And also, another thing, the temperature, the magnitude of the temperature is observed to be increasing. More precisely, the global average temperature is being observed to be increasing at a rate of 1.5 to 2 degrees centigrade every decade. Now it is every 5 years. So these various changes in the climatic pattern is being observed nowadays, where both frequency and intensity of such abnormalities has increased during the recent years. And as a change in this climate pattern, or as an increase in these extreme events, what is happening is different hazards are taking place. And hazard means, due to this hazard, what is happening? Disasters are taking place. Disasters means loss of life, loss of infrastructure, loss of economy, etc. Now, this climate risk assessment is a procedure by which we assess or we analyze the risk due to the change in climate of a specific location. Suppose if the average temperature of a location has increased by more than 2 degrees centigrade, then it can create disasters. It can create various extreme events and which can result in natural disasters. So, how much risk this location has from the or due to the change in the climatic parameters, this is assessed or this is analyzed in climate risk assessment procedure. And when this procedure is depicted in a report, that report is known as climate risk assessment report. Okay. That I have already discussed. What is climate risk assessment? Climate risk assessment, various authors and various reports define climate risk assessment differently, but more or less the basic definition is same. As can be seen from the definition given by the Predillion, Climate risk assessment, also known as climate change risk assessment, is a synthetic process to identify potential hazards from climate related events, trends, forecasts, and projections, so you can start developing a plan to avoid or manage this risk. So I have already explained you about the hazard from climate related event, and these events are caused by the change in climate, and these trends are also changing, and for these changes, whatever hazards is coming, these whatever hazards is coming, these risks need to be assessed location wise, or sorry, either location wise or industry wise, right? Or what can I say, area wise, district wise, plant wise, like this. Now, another definition says it calls for assessment of both risk and opportunity, side of transition and physical climate change impacts, and creates a reporting framework that allows institutions to prepare themselves upcoming regulation. So the basic thing is climate extremities, that is climatic abnormalities, resulting in hazards, which is resulting in disasters, which is creating impact on socio-economic characteristic of a location, of an area, of a district, of a country, of a plant, of a system. And this is a risk which, if assessed or if analyzed earlier or analyzed early, then probable mitigation measures can be adopted to avoid or manage these risks. So this is basically, in a summary, you can say, from these two definitions. And another definition is identification of risks to development activities arising as a result of climate change and of opportunities to address climate change. So this is basically the same thing. And there are various other definitions. So you can just look to the internet to know them. Now the next is, what are the 6 categories of risk into which the effect of climate change can be grouped? Yes, there are 6 different types of risk associated to climate change. One is regulatory, one is effect on supply chain, product and technology, litigation, reputation, and physical. By regulatory means, when a disaster occurs, we have to modify various regulatory measures that is existing in a place. We have to adjust the regulation. Supply chain means the supply chain, for example, water supply, electricity supply, or any type of product supply. These get affected when extreme events take place. These get obstructed. So to maintain the supply chain, what are the measures that can be adopted? And how much risk is there to the supply chain due to the effect of climate change? Suppose suddenly, for example, I can say in Bhubaneswar, in the year of 1999, October, a super cyclone has made its landfall in the Bhubaneswar and adjacent area. So total Bhubaneswar was destroyed. Plant various, they face loss not only in infrastructure, not only in economy, not only in social characteristics, but it has also lost its supply chain from the West Bengal or Kolkata, which various products come by road to Bhubaneswar. And due to this storm, this road gets affected. It is untravelable, untransportable. So the entire supply of product from Kolkata to BBSR was stopped for nearly 2 to 4 months. So that is the risk. If the climate risk assessment of BVSR was performed previous to the storm, then their government could have taken proper mitigation measures to avoid this risk. However, that was not the norm on those days, because on those days the impact of climate change was not observed so frequently compared to today, where anyone can say that there is a specific change in climate in most of the places of the world. So this is the supply chain. Then come product and technology. According to the climate change impacts, various innovations take place. Various precautionary products is invented or innovated. So product and technology innovation also take place due to hazards, due to the climatic hazards. One such example you can say that during the Maharashtra flood, some student developed a floating house. They made a house which can float in water. So when the flood comes, when other houses were submerged, that innovative house, the floating house, remained floating. So the people from adjacent houses also come and take shelter in those floating houses. So such type of innovation take place when extreme events happen. This is also true. Not everything is bad due to the extreme event. There is some good also. And also litigatory change, reputational change, physical damages are observed after an extreme event. That is not to be explained because they are already, you can see in the various news that comes after a landfall of cyclone or hurricane, whatever it may be. Now, what is climate change risk management? I have already said that main thing is managing the impact of hazards, right? To reduce the vulnerability of communities and landscape. Okay, and also to increase the resilience. You see, when a disaster happens, not only the disaster is need to be managed, but we must take steps such that the pre-disaster situation comes back to that location as early as possible. Take the example of BVSR. The cyclone made its landfall during the October 1999. Believe it or not, within March 1999, BVSR was made livable, and not only livable, they have improved much more compared to the status of the city before the extreme event. So the benefits that are enjoyed by the citizens earlier to the storm was increased many times after the storm. One reason is that the government became very cautious, very active. Another reason is that billions of donations were made to that city for the development, which has given Odisha government much more budget that they have allocated for the improvement of Bhubaneswar before the cyclonic storm takes place. So that is why what I am saying is climate change risk management means not only the managing hazards or reducing the vulnerability, but also to increase the resilience of the city. Right? So basically, climate risk management practices are designed to minimize the exposure to the risk, to manage the hazard efficiently, and to reduce the vulnerability of communities and landscape such that the damage is minimum. And also the most important thing is to increasing their resilience or to make the citizen fight back from the catastrophe they have faced during the supercyclonic events. Next is what is the indicators of climate climate change. I have already discussed about this, but this is the NOAA prescribed. NOAA means National Oceanography Society of this American, but they look after the entire world, entire oceans of the world. They have recommended that land surface air temperature, sea surface air temperature, marine air temperature, sea level, tropospheric temperature, ocean heat content, and specific humidity are the 7 main indicators of climate change. What is land surface air temperature? Yes, suppose this is the land and this is sea. The temperature here is the land surface air temperature. The temperature of air in the land is the land surface air temperature. What is sea surface temperature? Temperature at the sea surface is the sea surface temperature. What is marine air temperature? The air above the sea surface is your marine air temperature. Sea level, as you all of you know, the level of sea, water level of the sea. Tropospheric temperature, as you know, this is your earth crust. This is the atmosphere that we live. After that, there is troposphere, stratosphere, and various other spheres. So, if this is your troposphere, the temperature of the troposphere is this. And ocean heat content is the heat generated or absorbed in the ocean. Specific humidity, you all know the amount of moisture available in the air. So that is a specific, that is humidity. Specific humidity is a definition where it says that one unit volume of air, the amount of moisture content in 1 unit volume of air. That you can say as specific humidity under controlled atmospheric parameters. Now, main impacts of climate change. Yes, it is already discussed. Drought. There is storms, rising sea levels, but there is also drought. There is heat waves. There is melting glaciers. There is warming ocean. All these things are impact of climate change. If the temperature is rising continuously and rainfall is reducing continuously, drought takes place. If for the same reason, due to the massive disbalance in pressure in the atmosphere, storms take place. Heat waves, yes, heat waves. Rising sea level, melting glaciers, all are self-explanatory. These are all impacts of climate change. Now, this thing directly impact animals, human, destroy the places they live, and livelihood of those places also get impacted or get destroyed or get annihilated due to massive extreme events. There are various examples of this, not only in BBSR. There are super cyclones in USA, but they say it as hurricane. So there are, you can say California hurricane. Then there are in Philippines, then Japan, China, in various countries, massive hurricanes or cyclonic storm has taken place, has made its landfall, due to which massive amount of destruction was taken place or was observed on those locations. So it is said the justification of climate change risk assessment report. Now I have discussed all these things. Research observation confirm that the climate is changing and causing temperature and sea level to rise. Now, scientific analysis suggests that even if the world adopts strong future climate change mitigation measures, a further change in future climate and sea level is inevitable. That means climate will change. We cannot revert back. So that is why risk assessment measures has to be taken, mitigation measures has to be taken, risk analysis to be done. So that is why, or this is the reason why, nowadays every regulatory commissions, every country, government of any country is preparing climate change risk assessment report, because they know that climate change and its impact is inevitable. We cannot revert back now. Now, before going to the next topics, I want to define some important terminologies. Now you will say, what are they? They are related to CRA, climate risk assessment. So what are they? First thing is hazard. What is hazard? How a hazard is defined. Now, in the context of climate change, hazard refers to any potential occurrence of a natural or human-induced physical event that may cause damage to property, infrastructure, livelihoods, service provision, environment resources, etc. Right. So, suppose for example, if a sea level is rising above the average level or above the flood level, then the adjacent beach will be submerged in the sea. So, due to this rise of water, seawater is salty. The salt content of that adjacent land will also increase. Then what happens if uh, I know that in the seaside, very rare agriculture takes place, but coconut plantation is very common in the sea beaches. Any sea beach you go, you can find coconut plantation adjacent to the land, adjacent to the sea. But that also, coconut can strive in a specific, up to a specific level of salt content. When that level is crossed due to the sea level rise and submergence of land, then these coconut plants will suffer. The coconut plantation will suffer, and all the families that are related to this coconut plantation, the livelihood of those families will suffer. So that is being defined as an hazard. You see, they have given an example. When a sea level rise, increased frequency of inundation of area. Inundation means submergence. Submergence of area during a storm event or a sea level rise. Low-lying coastal community is under potential hazard. That means their livelihood will suffer. Right? Now, you see, this event can be due to natural causes or due to human-induced physical events. But the thing is, they can cause damage to property, infrastructure, livelihoods. Whenever they are damaging the property, then it comes under hazard. Whenever they are damaging property, infrastructure, livelihoods, even economy, environmental resources, etc., due to some event, that event comes under hazard. Okay, so any event which can damage the property, infrastructure, livelihood, economy, and the environment of a region, of an area, that event is known as hazard. Now, what is risk? What is risk? Risk is the potential for consequences where something of value is at stake and where the outcome is uncertain, recognizing the diversity of values. Risk is often represented as probability of occurrence of hazardous events or trends multiplied by the impacts or consequences. If these events or trends is a risk result from the interaction of vulnerability, exposure, and hazard. As I already said, what is the probability of occurrence of this hazardous event? That is actually risk. Risk is actually, you can say, the probability of occurrence of hazardous event. Okay? And yes, it is also that trends multiplied by the impacts or consequences if these events are trends. So if this main thing is that if an event is hazard, if it damaging properties, damaging infrastructure, damaging economy, damaging livelihood, then it becomes a hazardous event. And the probability of that event is known as risk. Okay. Next step is vulnerability. What is vulnerability? The propensity or predisposition to be adversely affected. Vulnerability encompasses a variety of concepts and elements, including sensitivity or susceptibility to harm and lack of capacity to cope and adapt. This is the definition given by IPCC, Intergovernmental Panel of Climate Change, in the year of 2014. Please note, regarding climate change, to analyze whether climate change is taking place or not, to manage, to take appropriate measures for avoiding that anomaly. All this policy for the entire world is prepared and monitored also by a committee, IPCC. The full form is Intergovernmental Panel of Climate Change. Here representatives of all the countries who have signed the Treaty of Climate Change in the first climate related conference. It is also known as COP. The first COP that was held in France. Those countries which have signed or will sign in that treaty, they are the member of this IPCC, Intergovernmental Panel of Climate Change. And this committee is entrusted to analyze, to manage, to take appropriate measures or policy measures such that we can monitor climatic change, we can manage climatic change, and not only monitor and manage, but also predict climate change. So this is the responsibility of IPCC. And according to this IPCC definition, vulnerability is that which denotes the sensitivity or susceptibility to the damages due to climate change. And not only sensitivity and susceptibility, but also the lack of capacity to cope and adapt to the damages caused by climate change or any other extreme events or abnormal events. This is known as the vulnerability. That means how sensitive is a location, how susceptible is a location to an extreme event, to a harm, hazardous event, and also the lack of capacity, to cope with the event, to mitigate the impact of the event, to adapt to the event, is also known as the lack of adaptability, what I say, is also known and comes under the vulnerability of that area. So if an area is vulnerable to climate change, it means that area is sensitive or susceptible to the climate change, and it's also lack the capacity to adapt to that climate change. Okay. And lastly, what is exposure? What is exposure? This the term exposure refers to the degree to which a system is exposed to a given hazard. You see, when a sea level rises, not the entire adjacent area is damaged. Only the low-lying areas are damaged. So, degree of hazards is more for low-lying area compared to high-end area or high altitude areas. So, for sea level rise, low lying areas are more exposed to the hazardous event compared to the high altitude area. So that is known as exposure. And this sensitivity I have already discussed in the previous slide. Now, If you say what is the sensitivity, I will say sensitivity is the potential of a location, of a region, of a system to be impacted by a hazard. Okay. So how sensitive is a system means to a hazard means how much effect or what is the degree of effect or what is the degree of impact that can be imbibed on that system or on that location due to a hazardous event. Here you see, mm, suppose a community uses a road for reaching to the major hospital. Okay, but for a storm, this road become inundated, right? So due to that extreme event, that community which is connected to that hospital, which provides essential services, as if the road is damaged, that community will miss those essential services provided by the hospital. That is why it can be said that that community is more sensitive to that coastal inundation events than those communities which are in proximity to that hospital. Suppose this is the hospital, this C1 community uses this road, C2 community uses this road, C3 community uses this road. Now due to the storm, this road become damaged, this road becomes semi-damaged, and this road is, there is no effect on this road. So what will happen is, you can say C2 is more sensitive compared to C1, and C1 is more sensitive compared to C3 to the hazardous event, which is the storm or the rising sea level. Okay, this is known as sensitivity. And here also climate risk assessment is two type. One is natural hazard based type and vulnerability based approach. In this natural hazard based type, you know what is hazard, which can cause damage. Based on that, if we assess the risk of a location, a region or a system, that is natural hazard based approach. And vulnerability, if you consider only the vulnerability of that location, that means how sensitive, how susceptible, or how much lack of capacity to adapt to that hazardous event. Based on that, if we assess the risk, then it becomes vulnerability based approaches. So there are two different aspects. Now, why these two are different? You know, when I am considering the risk due to hazard only, I am not considering the response from the location on which or on where that hazard has taken place. Suppose a storm has occurred. Okay. Now, if this location has already shifted the inhabitants from that location to another location, then the damage will be minimal. Life loss will be minimal. But if in another location that same storm take place, same intensity storm take place, but that location does not have the capacity to shift its local population to another place, then loss of livelihood will be more. So that is why if I only consider natural hazard based approach, then there is a drawback on that, because we are not considering the ability of that location to adapt to that extreme event, to adjust to that extreme event. Okay, so if we do not consider that, then our risk assessment may be erroneous. Okay, so when assessing the risk of a location, we must consider both cause and effect. But in case of natural hazard based approach, we consider only effect, not the cause. Now here I have, as I have discussed, what is risk for natural hazard based approach, probability of a climatic hazard. right, into vulnerability. That means this vulnerability is not your capacity of adaptation or sensitivity or susceptibility. This vulnerability indicates the extreme event, the magnitude of extreme event, and its probability. Okay, so here vulnerability does not mean that we are considering the susceptibility, sensitivity of that location or the capability of that location to adapt to that vulnerable situation. This vulnerability indicates the intensity of the extreme event. Okay, so you see, if the flood height, that means the due to flood, the water level, if I know that water level and we multiply with the probability of that water level, then we are getting a risk. This is your natural hazard based approach. Suppose I know that this river has a what I can say, this river can, or let us say, the maximum flood level or maximum water level of this river is suppose X. Now, what is the probability of an event which can raise the water level up to X? For accessing risk or analyzing risk based on the natural hazard based approach, what you do is you consider or you calculate the probability of this event which can raise the water level to MWL, maximum water level that can be stored in the river, right? That is P1, and you multiply with the magnitude of that water level. This will give you a natural hazard based risk. Okay. And in case of vulnerability of based approach, you see directly they are saying that what is the probability of a event that can exceed the criteria of vulnerability. This is also described as inverse method, and it is proposed by Carter et al. In the year of 1994. What is that? That is means that what is the probability that the water level will cross the maximum water level, and when the maximum water level is crossed, as you know, it makes flood and it submerges the low-lying area adjacent to that river. So it causes hazard. So they are saying that what is the probability that the water level of a river will cross the maximum water level, or in some places it is also known as flood level. Not only for river, if you are considering a reservoir, okay, there also there are various levels. One is flood level, right? Another one is highest level or maximum water level. Here it is low level. And the thing is, if the water level drops below the low level of a reservoir, then it becomes drought-like situation. It creates a drought-like situation, which is also an extreme event. Or if it crosses the flood level, then it will create flood. So that is also can be caused by an extreme event and can create hazard. Okay, less water means less availability of water. If water availability is reduced in such a manner that the local inhabitants lack proper supply of water, then it can also damage the livelihood or the economy of that those local inhabitants, and that will create a hazard, and that will make the adjacent low-lying areas of that reservoir vulnerable. Now, this risk saying that what is the probability that this reservoir will cross its maximum flood level? That is what will give you the risk. So this is more direct approach. This approach is also known as when you are getting, if someone say that suppose the reservoir level varies like this 100, 120, 150 and so on. And if I say what is the probability that the reservoir level will cross 150 meters, then how can calculate that risk? You will calculate by calculating the probability of the events, and the probability of this event will give you the risk of the reservoir as per the vulnerability based approach. So various examples of there for climate hazards and vulnerability. So this is, we have already discussed. The climate hazards are tropical cyclones, droughts, floods, or condition leading to an outbreak of disease also. And probabilities can be associated with the frequency, magnitude of the hazard. Now, these probability can be likely, unlikely, highly likely, like this. So these are various climate hazard and vulnerability. So this is I have already discussed. So next is types of climate change hazards. This is also very important. You see, there can be different types of hazard. There can be change in the variability and extremities. There can be long-term change or trends in average condition. There can be abrupt or singular changes. So when this is change in variability and extremity means the seasonality of rainfall droughts, when they are changes, then the hazard due to that change comes under this climate changes in variability and extremes. If the changes in peak precipitation intensity, flood risk changes, storm activity changes, heat waves changes, then it comes under the changes in variability and extremes. Example is, suppose due to 1,000 millimeter rainfall, if flood happens in a location, suddenly you are seeing that even with 800 millimeter rainfall, flood is flood is taking place. Then that is a change, and due to this change, the damages that can be caused due to change. Because you see, if this is 1,000 millimeter is their flood level, suddenly we are observing that even if with 800 millimeter we are facing flood in that area, then it is a big change in the extremes. And then the effect of this change can be classified under this type of hazards. Are you getting? Extremity change, extreme point changes. Some extreme thing happens due to this level of the cause. But suddenly we are saying the same extreme event is happening due to a lesser intense event also. So that is your change. This is big. This is can come. These hazards comes under this. Some hazard comes due to the change in long term. Suppose the temperature of area changes like this for 30, 60, 90, 100. Suddenly it is changing like this. This change will also cause hazard. And that type of hazard can be classified under this. If rainfall pattern suddenly changes, so rainfall pattern of the last 50 years suddenly is changing like this, then many things will face damage. Like the major damage will be caused to agriculture productivity of that area. So here, you see, this is also an hazard due to the change in long-term trends of the climatic parameters. And some abrupt changes also happen, like monsoon shifts, landscape and ecosystem transitions, glacial lake outbursts, etc. Monsoon shift, I already said, due to climate change, where when that in the last decade, monsoon was coming around June to June, July in some places. If suddenly in this decade monsoon comes within May, then it is a change. It is an abrupt change. And this change can also cause damage to agriculture productivity, not only agriculture productivity, various other related issues. Now, this can also happen if the landscape changes. Suppose the area was forest and suddenly an industry takes place. Industry is built by destroying this forest. Then runoff will change. Due to the forest, runoff was less naturally because the capacity, the retentivity factor of the watershed was more when the forest is more. But when the forest receded, the area of forest receded, then runoff becomes more because retention ability of that watershed also get reduced. So this change due to the increases runoff, yes, agricultural productivity will change. Also, the dams that are designed for that lower runoff will also get damaged as now runoff has increased. So, due to this abrupt or singular changes, also climate hazards happen. So these are the three hazards you can see: change in extreme, hazards due to change in extremity, extreme points, hazard due to change in the trend, long-term trend, and also abrupt or singular change due to monsoon shifts, landscape change, ecosystem transition, etc. Next is, this is the basic flow chart recommended in the technical paper 3. Okay, so not only technical 3, technical 2, 3, 4 like this. Actually, what happens, IPCC for risk assessment, they formed a committee. Okay, and that committee has prepared 7 technical papers. In each of the papers, technical papers, they have given or they have explained different types of measures that can be adopted to minimize the risk associated with climate change of a location. So these flowcharts show that how we can assess that climate, current climate risk, and how you can reduce the impact of that risk. So as you can see, that is the study team's understanding of the system. Under its investigation is well established, if the system understood by all participants. So they are saying that they will make different study teams or different case studies. Okay, and in this case study there will be participatory approach. That means people of those area will participate, right? And based on the feedback they are getting from those local communities, they will create that climate risk assessment, right? And there are various steps, so you can just go through it in the presentation, and then. But there is what I will say is that these are basically the steps to assess current climate risk of a location, of an area, of a district, of a system, of a plant, right? Now, how they are doing it? They are doing it by participatory approach with the stakeholders, right? So you see here, there are two types of team. One is with the stakeholders. This is two. Another is with a study team. That means these are the experts. These are the experts of respective field. That is a study team. They are connected to the stakeholders. They are taking the feedback from the stakeholders, and they are actually preparing this report. That is why what they are saying, that whether the expert have understood the system under investigation. Suppose this is a watershed. The behavior of the watershed must be well understood by the expert as well as the stakeholder of that area. Right? So they are saying that if both have understood, or they both have well knowledge about that system, then what will happen? Then you use some conceptual models to exchange information with the stakeholders. Right? If not, then we have to communicate with that group. If stakeholders doesn't understand the system, then you communicate with the stakeholder and educate them. If experts are not confident with the system, then you have to communicate with the experts to educate them about that system. And when both are, suppose both of them do not understand the system, then you have to build conceptual models by taking feedback with stakeholders. That means there can be three situations. One is both of them understood. Then go to the conceptual models. What is this conceptual models? I am coming. If expert understood but stakeholders doesn't, so you have to educate them. If both of them doesn't understand, then you have to build a model with by taking the feedback from your stakeholders. Now, by model I mean I already discussed about the natural hazard based approach and vulnerability based approach. Yes, I think risk by natural hazard based approach is natural hazard based approaches is what? Probability into magnitude of the extreme event, magnitude of the vulnerable event, and what is its probability that it will happen, right? But risk as per vulnerability approach is the probability of the extreme event. Okay, now you can use both the approach. Okay, and here also they have given some criteria under natural hazard based approach. Are the climate hazards, including likelihood of occurrence, well understood? The concept must be well clear to both the stakeholders and the experts, right? So they are saying that if no, then you have to collect data, analyze the data, and then assess the likelihood. Then only you can understand what is the event, extreme event, what is the extreme event they are facing, and what is its probability. But if you do not know about the historical data, then you cannot understand what is the extremity faced by that location, right? Suppose in Calcutta, the maximum temperature observed is around 39 degrees centigrade. That this is an extreme temperature with a probability of what I say around 10%. More or less, the temperature of Calcutta during the summer stays within 35 to 37. During winter, it comes to 10 degrees centigrade also, but more or less it remains under 15 to 15 and up. So you can say the both extreme of temperature in Kolkata is 15 to 37 degrees centigrade. So if you do not know about this behavior of Kolkata, the temperature behavior of Kolkata, then you cannot analyze the risk. You must know what is the minima and maxima, or the two extreme of the average temperature of Kolkata, daily temperature of Kolkata. So that is why you have to know the data, the historical data. Then only you can go for that conceptual model, either by natural hazard based or vulnerability based approach. So then the next question is that the relationship between the climate and its impact is well understood. If low, then impact analysis has to be created. If the relationship between impacts and vulnerability well understood, impacts and vulnerability well understood. If low, assess the vulnerability, decide the criteria for vulnerability. If yes, then go to that current vulnerability. Current vulnerability means the criteria. What is the criteria of vulnerability that you will use? If you are using vulnerability based approach, if you are using natural hazard based approach, then you have to know the magnitude of that vulnerability, that extremity, and then you have to multiply it with the probability. So after doing all these things, you you have to again ask a question that historical adaptive response. What are the historical adaptive response needed? What are the adaptive method followed in that location to avoid this risk, right? So if there are well established adaptive measures, then you can go for future climate risk. But if there is no such thing, then you have to prepare the adaptive measures also, right? So that is the overall the process of assessing climate risk. Remember that first you have to know that whether your expert understood the system, whether your stakeholders understood the system. If both understood the system, apply the conceptual model. Conceptual model is risk analysis based on natural hazard, risk analysis based on vulnerability based approach. Then what happens is if stakeholders doesn't know about the system, educate them. If both of them doesn't know about the system, build the concept model by the feedback of stakeholders. Right? Now after this, you have to see that in natural hazard based or vulnerability based approach, the data, that means the data or the criteria of vulnerability is well understood or not. That has to be pointed out. Do you know that above which value of temperature hazard can take place? That is the question that you must know. If you do not know, then you collect historical data and identify that thing. Okay. Then you have to identify a relationship between the climate and the impacts. That is, if the criteria is met, if the vulnerabilities take place, then what will happen? What are the impacts that may happen? If you do not know about the impact, then you have to create impact analysis model. Then you have to see what is the vulnerability and impact collection. That means what are the impacts and how vulnerable or how adaptive or how susceptible is the area for that vulnerability or for that impact. Okay. And if that is not known, you have to assess the vulnerability. You have to make a vulnerability assessment. Okay. And in case of vulnerability based approach, same thing, vulnerabilities are understood or not. If not, then you analyze with the help of baselines, that means the data, assess vulnerabilities, to decide the criteria. Then again, whether the relationship between vulnerability and climate impact understood, is the relationship between vulnerability and climate hazard well understood. If no, then you have to construct impact analysis model. If yes, then go direct for accessing the current vulnerability. So you see, in case of vulnerability based approach, one step is lesser compared to natural hazard based approach. So with this, I will conclude the first presentation regarding the climate risk assessment, and we'll discuss about the different risk analysis methods in the next presentation.